Hey everyone, in this video we're going to be looking at merge sorting, what it is, why it's helpful, and how you can get started thinking about it and using it. If you haven't seen the recursion video from earlier, I would highly encourage you to check that out. No doubt I'll have a link in the description below. So that aside, what is a merge sort? You can watch this in action on the profile picture from the Wikipedia page. It is a way of sorting an unordered list of items like an array of numbers and has a pretty efficient n log n time and space cost. Conceptually, a merge sort is based on the insight that a one-element long array is already sorted. So if you have a long array that's out of order, you can just break it into one-element arrays, compare those, and then you're done. No big deal. Actually, it's kind of a big deal, and it's not very intuitive, but hopefully you'll find this illustration helpful. Let me execute a sample code. I believe it's also from Wikipedia. Let me execute that for you a couple times, and then we'll go into the particulars of what's going on. So there are two methods that go into it. One is the actual merge sort algorithm, method. And then the other one is a helper that does the merging. The merge method does this is where the comparison is done, and then a merge sort does the unzipping and rezipping of a long array into single element arrays and then handles tying them all back together. So we'll just go line by line here and see what happens. The first line here, which on the file is line 59, is pretty intuitive, and that is return the array if it has only one item in it. Now that is our base case, and that's what we're targeting. That's what we ultimately want for our long array to be a bunch of individual element arrays. If it is not meeting that condition, then what we're going to do is set two variables, left and right, to be the result of, and this is where the recursion starts, the first half of the array, which is 0 to index length divided by 2, the middle, and then the quote-unquote right side of the array is set as the right variable here, or technically right is set as the return value of calling the merge sort method on the right half of the array. So that is a little dicey to visualize. So let me show you basically what the lefts and rights look like here. So this long array goes in, it goes through the recursion. Recall that recursion doesn't allow a method to execute completely until the base case has been satisfied. And so you sort of see the very end of the recursion rabbit hole happening first, and that's why you don't see like left is 10 through 6 and then right is 5 through 1. You actually see that left is 10 and right is 9. And then it's 7 and 6. And then it's 8 and then 6 and 7, which we'll get into why that's the case in a second. You see that phenomenon happening, and that's just something to be aware of, and that's like one of the less intuitive pieces about recursion in general and of this method in particular. But that's basically what happens. So it sets these left and right arrays. Sometimes they're only one element long, sometimes they're more, as you can see, especially down here once you're getting close to the end. And these left and right variables now get sent on to the helper method, which does the merging, and that's what comes next. So there's a base case for the merge getting broken, or actually, sorry, there's not recursion going on in the merge method. There is a loop that says while there are still elements left in them, and then there's a condition if the first element of the left array is less than the first element of the right array, then shift. And what is shift? Shift is the method in Ruby that takes the first element off of the element or off of the array that you're calling it on and returns it. So in this case, it's taking the first element of the left array, deleting it from the left array, and returning it. And what does that do? Well, it puts it in the result for you. If the first element on the left is less than the right, the left one goes in. Otherwise, the same thing happens, but with the right array. And what gets returned is that results array concatenated appropriately. So this is what happened. And actually, why don't I pretty print that as well? So now we're pretty printing the result of the merge method getting called. And you can see at the beginning it's 9 and 10 because the left and the right were 9, or actually they were 10 and 9. In fact, why don't I just uncomment all of this for you? So the left that's getting passed on the very last, like the end of the recursive call, it passes a 10 for the left and a 9 for the right. Then it goes through the merge, and the result of that is that you get 9 and 10. Then the next call in the recursion passes 7 and 6, and the result of putting that into merge is that you get 6 and 7. Then your one on the left is 8, and you've got 6 and 7. Now we're like one or two layers back up the recursive chain. So it's now 6 and 7 rather than just a one element array getting passed. And that gives you 6, 7, and 8, and so on, all the way down until finally your left is 6, 7, 8, 9, 10, and your right is 1, 2, 3, 4, 5. And then you merge those, and there it is for you. The reason why the sorted array is showing up twice is because of having a pretty print down here. But if you got rid of that, the very last thing that comes out of this merge sort, which is the ultimate return result, is the same as the result of merge getting called for the final time. So that's a lot to think about and chew on. I hope that it was helpful, and I'm already looking forward to seeing you in the next one.